When people talk about robots, they usually focus on the brain. They talk about AI models, software, and computing power. But in the real world, the robot body matters more than many people think. We constantly hear these endless debates about massive computing capabilities. But out there on the factory floor, or in a busy warehouse, the physical hardware is actually doing the heavy lifting.
A smart robot brain is simply not enough. You can equip a machine with the most powerful AI available, but if its physical body is mismatched to the task, its performance will inevitably suffer. In high-stakes environments, robots just don't succeed on intelligence alone. They win when the brain and the body work in perfect harmony. Think about it. A brilliant AI doesn't mean much if the hardware literally can't keep up with the workload.
So, what exactly makes up the robot body? Well, it's a lot more than just metal and plastic. It's a complex business system made up of 6 critical physical elements: the actuator, the reducer, the motor, the sensor, the structure, and integration. Let's break these down to see why they're the true drivers of operational success. Let's start with the actuator. You can think of this as the robot's muscle. It's entirely responsible for creating movement and generating physical force. Without a highly capable actuator, the robot fundamentally cannot lift a heavy pallet, grip a fragile component, or press with the exact force required for a delicate assembly. But muscle alone isn't enough, right? You need control. And that brings us to the reducer, which is often the hidden secret inside the world's most successful robots. Its job is to convert raw speed into highly usable torque. So while the actuator provides that initial motion, the reducer acts as an essential precision layer, making sure that motion is stable, deliberate, and exact down to the millimeter. Driving all of this is the motor, the core power source behind every single movement. Different motors yield drastically different levels of speed, efficiency, and control. 2 robots might look completely identical from the outside, but their real-world reliability relies almost entirely on the quality of the motor humming away on the inside. Next up, we have the sensors. These act as the robot's eyes, ears, skin, and even its sense of balance. They're constantly out there detecting position, force, distance, temperature, and vibration. You could buy the strongest physical frame on the market, but without continuous, hyper-accurate environmental feedback from its sensors, that robot is basically operating blind. Then comes the structure itself, which really dictates the physical fit. This encompasses the frame, arm geometry, weight balance, and the overall design. Structure directly governs a robot's reach, stability, and crucial safety factors. We've all seen robots look incredibly impressive in a tightly controlled vendor demo, only to fail on the floor because their physical structure just didn't match the messy reality of the worksite. Bringing it all together is the final element: integration. This is truly the make or break point for any automation project. A robot body isn't just a shopping list of parts. The actuators, reducers, motors, and sensors must communicate flawlessly. Plus, the entire unit has to integrate perfectly into your existing workflow and operating environment. If it doesn't fit the site, those individual specs simply don't matter. Understanding how all these elements connect leads to a crucial realization for anyone investing in automation. Your selection process should never rely solely on an attractive price tag or those headline-grabbing AI features. Instead, the single most important question you need to ask is simply this: does the physical robot body actually match the demands of the job? To accurately answer that, buyers should use a practical 5-point checklist. First, payload. Can the structure handle the physical weight without straining? Second, precision. Can it execute movements with the exact accuracy your product requires? Third, cycle time. Can it repeat this task efficiently, all day, without burning out the motor? Fourth, work environment. Can the sensors and frames survive your facility's heat, dust, or tight spaces? And finally, maintainability and integration. Can it be maintained without causing constant downtime? Checking these boxes is absolutely crucial to ensuring a stable return on investment. Because a physically mismatched robot simply won't deliver that stable ROI. True success happens only when the body, the control system, and the site conditions are in complete alignment. Look, in the world of robotics, intelligence absolutely matters. But the future market belongs to companies who understand that the physical body is what actually turns that brilliant intelligence into real work, superior output, and lasting value. eXGateAI is a growth partner for small and mid-sized companies. Your scale engine.